Thanks everyone for joining. My name is Nathan Bacchini. I am a marketing manager at Data Science Dojo, and I have Alexi. And Alexi, I tried to pronounce your last name yesterday, and I probably butchered it, so forgive me. Grigorev?
Yeah, close enough.
Close enough. Okay. But I have Alexi here with me. He's a principal data scientist at OLX.
That's right.
And obviously, we just mentioned he lives in Berlin with his wife and son, and he also runs Data Talks, which is just a place to talk about data. So, Alexi, I'll let you go ahead and get started with deploying machine learning models with Flask and Docker. Like I mentioned earlier, if you have questions, use that Q&A tab. Help us keep everything organized. We will make sure to answer questions as we go. And then if you're on a live stream, ask your questions in the chat. We'll pull them into Zoom for you. So, Alexi, why don't you go ahead and get started?
Okay, thanks a lot for having me. So I don't think I will be able to pronounce your last name too. So, okay, so let me start. So I will actually use this thing. So this is a book I wrote. So it's called Machine Learning Bootcamp. And what I want to do today is open chapter 5. And this chapter 5 is about deploying machine learning models. And I just want to work through with you today through this chapter. You don't need to have the book to follow this. So this chapter is quite standalone. We will, however, use a model from a different chapter. So here in this talk, I assume you already know a bit of machine learning. But if you don't, it's fine. Then you can maybe come back later and check some of the materials for today. So let me start. I will share my screen now. So I'm sharing my screen. So yeah, actually, speaking about the book, so there is a course based on the book. It's called Machine Learning Zoom Camp. So it's kind of funny. The book is Machine Learning Book Camp, and the course is Machine Learning Zoom Camp. Right. So the course is available on this link, ML Zoom Camp, and everything I will say today is available in the course repository. So in the course repository, we have this 0.5 deployment. And this is the code we will use today. So we will, actually this code. So we will now create something similar to what we already have here. So later, when you want to come back to the materials of this webinar that we will have today, you can come to this module 5 and check it out. And of course, you're welcome to sign up for the entire course. It's free. But yeah, let me start actually with saying what exactly we will cover today. So first, we will take a model. So this is a code for, let me enlarge it a little bit. So this is the code for producing a model. And what this model is doing, it's predicting if a customer of our company will churn. So we can imagine that we work in a telecom company and we give different services to people. Like, I don't know, internet services, landline, land phone services, and things like this, right? And we have some clients, and some of these clients might decide to leave our company and go to competitors. And what we want to do is we want to identify those customers that are about to leave us and go to competitors, and perhaps propose them some discounts or somehow convince them to stay with us. So let's imagine we have a large customer base and we want to score every customer on this customer base and identify those who might churn. And then those who churn, we want to send them some promotions and convince them to stay. So for that, we will use this code. We will use this data set that actually I think I took from Kaggle, telco dataset Kaggle. Let me try to find it. Yeah, this is the data set, telco churn. So in this data set, we have different, let me enlarge it. We have different characteristics of customers, like gender of a customer, whether they are senior or not, whether they live with partner, whether they have dependents, like kids, how long they are with the company, and things like this. And at the end, which is something we don't see here, is at the very end, we have this thing called churn. So, and which is yes if they left and no if they didn't. So based on this data, we want to train a model for predicting customers who will churn in the future, who are likely to churn. I already have the code for this, so we will not talk exactly how to train this model. So this is something that you refer to module 3, I think. Yeah, this classification model of the course and the book too, to see how exactly this model was trained. So we will not talk about this here. So here we will talk about the moment when we already have a model and we want to go and deploy it and start using this model. And for that, so first we will execute this code and save the model. We will save it to Pickle. Pickle is like a special format for saving the model. Then we will load this model from a different process. We will see how to use this model, and we will serve this model with Flask. Flask is a special web service for Python that could be used for serving the model too. Then we will see how to manage dependencies and create a virtual environment. We will use a tool called Pipenv for that. After that, we will package everything in Docker. So we will have a Docker container. We will put everything inside this container. We'll create a Docker image. And then at the very end, we will take the Docker image that we created and publish it to the cloud. So we'll actually deploy this and it will make our web service, our model available. So that's a lot of things to go through. So let's get started. So I just want to take this notebook and execute it. You don't have to understand what's going on here, but you can always refer to this and see the code. So what I'm doing here is I'm training a logistic regression model. So this is the logistic regression model, and I'm determining what is the best value of C. So C is one of the parameters of logistic regression model. And yeah, so here I am doing cross-validation here. I actually don't know why I need to do this. So let me just remove this. So at the end, I want to train the model. So I use this train function. I use the C value of 0, C value of 1, right? So I train the model, and then I evaluate the quality of this model, and this is the quality, right? We have a model. So this is model. So this is the model we created here with C equals 1, and we want to save it. So for this model, we actually need to save two things. So we need to save the model itself. Here's the model, and dictionary vectorizer. So this is a thing we use for pre-processing data. So if you don't know what it is, we will see this later, how exactly to use this. Don't worry. But yeah, so we need these two things to save. And Nathan, can you please mute yourself? Because I think I hear you. It's a bit distracting. Yeah, thank you. And now, so we saved it. And now I want to show you how we can load this model. And then if you don't know what dictionary vectorizer is, you will also see right now what exactly this thing is. So I will start with importing the Pickle file, the Pickle model. So this is the model for loading, like saving and loading Python objects. And I will load the model that we just saved. So this is the file that we just saved. And I will load it in the reading mode and in the binary mode. So RB, then so this is how we open files in Python. And then I will just say, so Pickle load and this file fin. And then it returns. So this thing returns. So if I just load this, it loads the file and returns something. And it returns what we saved, which is dictionary vectorizer and the model. So I load them. So now we have the dictionary vectorizer and we have the model, right? And now we need to figure out how exactly we can use them to make predictions. So let's say we have a client who is our customer, right? And we want to identify if this customer wants to leave us, churn or not. And I will just take a random customer, I don't know, customer number 4 from our test set. So I will save it as a dictionary or show it as a dictionary. So this is the customer who did not churn. So she stayed with us for 10 months and she still stayed. So, and this is, so this is the description of our customer, right? So I now will take this. So it will be our customer and Yeah, so we have this customer, and now, yeah, we know that she actually didn't churn, but let's pretend we don't know if she churned or not, right? So we have her in our customer database, and we want to understand if she will churn next month or not, or what is the probability that she will do this next month. And we have this dictionary object. So what we need to do with this dictionary object is somehow turn it into something we can put into a machine learning model. And for that, this is exactly why we use dictionary vectorizer. So dictionary vectorizer can take our dictionary and can turn this into something that we can put in our machine learning model. So then it turns the dictionary into zeros and ones, right? And this is exactly what we can put in, we can put in our model. And then I do model predict. So I do model predict proba because I want to predict probability. And then I see that for this customer, the probability that she will churn is 23%. So I actually need just this number, right? So this is the probability that she will churn. And I can just say that this is Y prediction, right? And then I can do something like just print it, right? So this is how we save the model. This is how we load the model. And this is how we take a customer, which we want to score. And this is how we score the customer. And then we can implement some logic based on, I don't know, whatever rule. Let's say if this is higher than 50%, then we can send a marketing email to this user. Right, so this is what we've done so far. Let me take a sip of. Okay, so now we've done that. And now what we will do is we will create a virtual environment in which we will take this thing and put it into Flask, into a web service. So I am going to terminal right now. So this is my terminal. And this is the same location where I open Notebook, right? And what I have here is, yeah, just a bunch of things. And I already have Pipenv. So Pipenv is the tool we will use for managing virtual environments. And we want to create an environment where we will have all the dependencies we need for this particular thing. So to create an environment, we do pipenv install, and we need to install a bunch of things. So the first thing we need to install is Scikit-Learn, right? Because we use this model and this dictionary vectorizer, they come from Scikit-Learn. So we need to install Scikit-Learn, and we need to be careful because we want to make sure that the version of Scikit-Learn that we have in our virtual environment is exactly the same as we used for creating our model. So I will just do quick import. I will import Scikit-Learn, and I will see what is the version of Scikit-Learn that I used for creating this model. So this is the version. So now when I do pip install Scikit-Learn, I specify the exact version that we need. And then we also need a bunch of other things. So we need Flask for serving it. And for now, let's just leave it at this. So just Scikit-Learn and Flask. Yeah, and I don't know what's happening here. So I think because in this folder I already created something, so I'll do pipenv rm. Okay, yeah, because I think in this folder I did a workshop some time ago. So typically you will not need to do this pipenv rm. Actually, another thing that I might need to do here is specify the version of Python. So for that, I will do something like Python. I will use 3.9 for this. So we can specify the version of Python we require for the project here when we create too. And you see that it says that we use 3.9.7. Because I also, on this computer, I also have Python 3.10, and 3.10 is a bit too fresh. So I don't know if all the libraries will work here. And also in this folder, I have Visual Studio Code. So this is where we will create code right now. And the first thing I will do is I will take the notebook that we created here and I will turn this notebook into a script, into a Python script. So first I will rename it. So I'll call it, I don't know, predict. So this is the name of the notebook. We have it here. And now I will turn this notebook into a script. So I'll do Jupyter NB convert. So this is a command for converting a notebook to script, to script, and then what's the name? Was predict. Right. So now what will happen is we will create this predict.py file, which is here. And now I'll just clean this file a little bit. And that's basically what we did in the notebook, right? So we have customer, we have this bit of code. So loading the model, applying dictionary vectorizer, applying the model, and then printing the prediction. So I think that's pretty much all it does, right? And now I want to execute this code from our virtual environment. For that, I will do pipenv run, or I'll do pipenv shell. So this kind of activates the virtual environment. So you see we now have this deployment workshop here thing. And if I do which Python, it tells us which exact Python is used for that. So it's Python that lives in this virtual environment. Okay, that doesn't matter. So like it's not important. Maybe if you're not really following what I'm saying here, like here, I am making sure that we use a separate Python, not the system Python, for what we are going to do here. Anyways, so here now I will execute. There are some questions, right, Nathan?
Yeah.
So let me just quickly execute this thing, and then we will cover the questions. So I'll just do Python predict. So we're doing this in a virtual environment, and we see the predictions. And yeah, what's up?
So this person is just wanting to know if this is a virtual machine or not.
It is a virtual machine, yes. Because I am on Windows, you might see this Windows, and I just had a virtual machine in AWS, so which is this virtual machine. You can see the API. I hope you don't use this API in any way, but it's a virtual machine. Doesn't mean you have to have a virtual machine too. You can just do everything from so on Windows, I use Git Bash for everything. So this is just, it's like a Linux-like environment, but for Windows. Or alternatively, you can use, so on Windows, I have VSL, which is Windows Subsystem for Linux. That is like usual Ubuntu, but on your Windows. But for different reasons, mostly Chrome eating all my RAM and not having enough RAM for doing a workshop. And then also at some point we will do some stuff related to AWS, like uploading images. It's a lot faster to do from a virtual machine. That's why I use it. But for you, you can pretend you don't know about this, and I'm doing everything on my local machine. Yeah. Yeah. Okay. Are there any other questions, by the way? I see there are a lot of things in chat, but I don't know if there are.
There's one other question, but I think we should wait till the end to answer it.
Okay. So yeah, so we have the predict script, and now we want to turn this predict script into an actual web application. So something that we can use for making requests and getting responses with predictions. And for that, we will use Flask. And I just want to quickly check. So I want to look in the book to make sure I don't forget anything. So yeah, so let's turn this into a Flask application. And for that, we already imported Flask. We already installed Flask. And I'll just do import Flask here. Sorry, not like that. From Flask, we will import Flask and a bunch of other things. I will need to take a look what exactly. Do you have, Nathan, are there any questions?
There are more questions now.
Yeah, so what's up?
So while you're taking a look, and I'm not going to say these right, is Pipenv like virtual env?
Yeah, it's exactly like that. So Pipenv, Pipenv, so it's Pipenv. So Pipenv is a wrapper around virtual env. So it just makes it easier for you to interact with virtual environment. But it's nothing else as like a wrapper around virtual environment. So I actually wanted to show you this file too. So this is what Pipenv created when I did Pipenv install. So when I did this here, right? So when I did this, it actually created a file, this file, where it specified dependencies. So it is similar to requirements.txt, very similar, except that it has a bunch of other things. So for example, also Python version. And more importantly, it has this pip file log file, right? And here it logs specific versions. So for example, for Flask, it expects that the version of Flask is this particular version of Flask, and these are checksums of files coming from Flask, right? And if something happens, like when you try to install and the file is corrupted, Pipenv will let you know about this. So this is quite useful. So even though when we say here, so when I say pipenv install Flask, when you usually do this, usual pip by default just fetches whatever latest version is available. Pip is doing the same, but it locks the version. So when you use this pip file log, then it will install the same version for Flask as I did, which is very handy. And then, like if it works on my computer, it will also work on your computer. And I will not be able to say, but it works on my machine, because it will work on your machine too, hopefully.
So does the same deployment process work for deep learning models as well?
To some extent, but yeah, I'll have to make a shameless plug here. Sorry. But in the course, we cover. So deep learning is a bit special because the libraries for deep learning, they're heavier. In principle, you can follow the same process as we show here. But let's say if you use TensorFlow, then you can use things like TensorFlow serving. And we actually have two modules about that, serverless and Kubernetes, which are about deploying deep learning models. But again, what I show here will also work, but there are better ways.
Okay.
So end of shameless plug.
And then we'll do one more question and then let you get back to it. Can we use some free platform other than AWS to predict?
Yes, of course. So everything I show here, except the last part, is platform agnostic. And on the last part, I will show you how to deploy it to AWS Elastic Beanstalk. But this is just one of the options. So with a Docker container, you can deploy to pretty much every cloud that supports Docker container deployment, and there are many of them. So AWS is one of them, but you can also do it with GCP or or have your own local Kubernetes. With Heroku, it's a little bit different, so you don't need a Docker container, but most of this stuff will apply to Heroku too, for example, or to Python Anywhere, or I actually don't remember if I can deploy Docker containers to Heroku. But most of the stuff that I will show here today is pretty generic. It will work for pretty much everything, except for maybe last part where it's very AWS specific. Okay, should I keep, because I see that it's already like half of the webinar.
Yeah,
so I need to hurry a little bit. So now we need to import a few things. Request JSONify. So here, what I do is I now want to turn this thing into a Flask application, and I just need to import a few things for that. So first of all, Flask will let us create a Flask application. So I'll call it up, and we can call this application churn. I don't know if it's really important to give a name. Then we will not need this because we will send this in a request. I will just copy it to a different file. And then here, this thing we need to put inside a function. So I'll call this function predict. And this function will just do this thing, but instead of simply returning the prediction, so we will, I'll call it result. And then in this result, we will say churn probability, and let's say it will be ypred. And Yeah, and at the end, I will just do return JSONify. So JSONify turns the dictionary that we have into JSON object. So this is the format we use for communicating with between clients, between web services. So the client sends a request in JSON. Then we, the web service, gets this JSON, parse it, turn it into a Python dictionary, then execute this, and then convert the result back to JSON and send it back to the client. And yeah, as I said, the customer is also, we receive this customer as JSON. And for that, we need to do something like request.getJSON, I think. So I don't have autocomplete here. I hope I'm typing in correctly. And then now we need to say that this function is actually an endpoint. Endpoint is like we just want to say at which address this function lives. So I just say app.route. If you ever created an web service, you probably know what it means. If you did not and you feel lost, it's fine, because later, like in a couple of minutes, we will show you how exactly this is going to be used. So here I just write, so this is address, how exactly we will access this function, and the HTTP method. So there are many different methods, so we will use post. So if you don't know about them, you can Google HTTP methods, get, post, put, delete, like things like this, and then you can see what exactly it means. So for this one, we will send request our customers using the post method, using this address. Right? And that's pretty much all we need to actually start serving our clients, to start serving our model with Flask. And there is just one last line when we need to start our Flask application. So we do up run, debug true. Debug true helps us, let's say, if we make some changes here in this code, because if we run it in debug mode, it will automatically restart it. And then we will also need to say host. So host is 0000. So it's important that it's not localhost, but 0000. Because like there is a distinction between localhost and 0000. When it's 000, it's just too many zeros. Anyways, when it's like that, then yeah, it will serve like all the clients. Okay, I think like if you're really interested in what's the difference, you should Google it, and there is a good Stack Overflow answer about that. And then port, so this is the port that is listening to, it's 9696. And then if you know Python, you need that if we want to run something, then we need to do thing like this, right? So this is our main block in Python. And I think that's pretty much it, right? So I think, so we import Flask, I don't need JSON. So we import Flask, we import Pickle, we load the model, we create a Flask app, then we put all the logic here in the predict function, and then we turn this predict function into an endpoint, and then we start our web service. Now let me run it. So to run it, what I will do is just run this again, Python predict, and you will see that it starts a Flask application on this address and on this port. So now I will go back to our Jupyter Notebook, which is here, and we'll use a special model called requests for making a request to this web service. So URL, which we will use for sending the request, is HTTP. It's localhost 9696. So this is the address where we will send our request, and the actual address is predict. Right? So this is the host, this is the port, and this is endpoint that we use. So this will be our URL, and we will send a post request. So we will use method post, then this is the URL, and this will be the customer in the request that we will send to our web service. So I'll copy it. So this is how it should look like. Post, then we send this data in JSON. Customer equals JSON. And I don't think we need to do anything else. So I just execute this. And yeah, so it gives us some response. So actually I need to save this response to a variable so we can later see what the response actually was. And response was in JSON, so we need to parse this response. And yeah, that is the response, right? So this is how it works. Okay, yeah, that's it. So we were able to send a request and get back the response. I'm actually surprised it works. I was expecting it would fail here, but okay, that's good. What's up?
Oh, we have a ton of questions if we have a little bit of time. So let me get to, this is from Bernardo. There's been some rivalry between Pipenv and Poetry due to dependency management. Do you use Pipenv in production? Have you had issues with it?
So we do use Pipenv in production. So we're at work, where I work at OLX, every new projects use Pipenv. At some point, we just decide, okay, we just need to stick to one tool. But yeah, we didn't have any issues. The only thing I don't like about Pipenv is about sometimes it's slow. So when, let's say, you already have 20 dependencies and you want to add 21st one, then it's sometimes slow, right? Other than that, yeah, I didn't have really any issues with this.
Okay. And this is from Mehdi. Is Pickle always the preferred way to save the model? What other format would you recommend?
Yeah, actually, it's not always the preferred way. So with Pickle, you should be careful. So you really need to trust the source. So if you know that this Pickle file is coming from your job, then it's safe to load. Because with Pickle, it's possible to add some arbitrary code that will be executed. So you shouldn't unpickle any random files you found on the internet. Right? So don't do this. So that's kind of not safe, but if you know that you produce this file, then it is okay. So that's this warning. Apart from that, Pickle is just easy to use. It comes like it's the built-in package that is everywhere. Like every Python has it. So I don't see reasons not to use it. Apart from Pickle, there is Joplib, which is pretty much the same thing, but I think, yeah, you can also use this. So it's instead of Pickle, you would just import Joplib and then use Joplib for saving the Pickle file. There is like slight difference. I don't remember which difference is it. And then there are formats like PMM8 or something like this, when you actually save the model as XML file, not Pickle, which is like more cross-platform. And then it definitely has no, like if somebody wants to hack you, they definitely have no way of injecting any random code in this PMML file. But yeah, Pickle I think is just the easiest one.
And can we add an emailing function in Flask?
Not in Flask. So actually, so here in this example, so this is the client. I know customer and client is confusing. So here by client, I mean, let's say we have a marketing service. The marketing service uses our churn predicting service. So for each client we have in our client database, it's for each customer it sends a request to the churn service and gets a response. And then this marketing service can decide, okay, if the probability of this, or actually what I should do instead, here I can have a variable called churn, which is if y spread is higher than 0.5, then I return churn, right? So I will, now if this thing returns true, then the marketing service will send the email. So it's not this service that sends the email, but the service that uses this service. I know it's confusing, but it's not your Flask's job to send emails, but the users, the people, the other teams who use your service, it's kind of not responsibility, but like this is what they should do. So they use your service for predicting churn, and then they do what they need with this thing. And now let me try to, I see there is an issue. I think I might need to restart it. Yeah, now when I do this, we see, okay, now this is the problem I set we should have, because now I need to turn this into I will explain you what I'm doing here, but let me just check that it works, and then I will explain what's happening. Okay. Live demos are always like that. Okay, cool. It's working. So we see that it's churn false here. It means that this service here, we assume that we are a marketing service, should not send an email. But if it was true, then it would send an email. So we don't do this from here. And then coming back to this problem. So here we saw this weird error. Object of time bool underscore is not JSON serializable. So if you see this for the first time, it might be super puzzling, like, okay, what the hell is going on here? And the reason you see this is because this bool underscore object is coming from NumPy. So NumPy is something that Scikit-Learn uses internally for like this actually. So this ypred is a NumPy number, not the usual Python number. And yeah, just JSON library that we have built in Python, it just doesn't know what to do with these NumPy numbers. And we need to help it a little bit. So we say that it's actually relax. This is a usual number. Relax, this is a usual bool type. So we explicitly convert it to built-in Python types. And then it knows how exactly it should serialize them. So that's what's happening here. So we turn this into a float. Instead of using NumPy float, it's a Python float. So these are different floats. And then this one, actually, this one should already be a Python float. So like there should be no need to cast this here. I'll just in case keep it here. Do we have any other questions?
We do, but I want to make sure that we have time to.
Okay, so because now we already have a web service right now. We can interact with this web service from our, let's pretend this is our marketing service, right? So we can already interact with this from our marketing service, and we can make decisions here. So for example, we can see, as I said, if churn true, then we send emails. We will not write code here for sending emails, but yeah, you can do that too if you want. And yeah, so we have that, and now let's deploy this to Docker. Maybe before that, we should also, why it's doing this. And before that, I want to talk a little bit about this line. So you see, it says this is a development server. Do not use it in production deployment. Use a production VSGI server instead. So what it wants to say, to tell us here, is that Flask comes with built-in server, web server, but it's very limited. So you can only use it for testing your application. But if you want to deploy it, it will not be able to handle your load. And it says that, yeah, for testing it's okay, but if you want to deploy it, use something else. So what this something else is like there are actually many. So let me stop it. Yeah, I stopped it. So there are a few VSGI servers. We will use here GUnicorn, which is one of them. So if you're using Windows, GUnicorn will not work, and you will need to use a thing called Waitress Python. It's pretty similar to GUnicorn. We will use GUnicorn here. And later on, like even if you're on Windows, because later we will put this in Docker, and then in Docker it will be Linux. So you can just skip the part where you test it locally if you're on Windows and move on directly to Windows. So I will install GUnicorn here. So I'll do pipenv install GUnicorn. And then, yeah, it will take some time to install. So this is the part about Pipenv that I don't like. So it's doing all these resolving dependencies, and sometimes it's taking a bit of time. But yeah, when it's just a few dependencies, it's not that bad. So now I want to show you how to use GUnicorn to serve our model. And again, if you're doing this on Windows, it will not work. It will complain about some missing dependencies. So just you can skip this part, and later we will do this in Docker where it will work. So gunicorn, I think bind, we say which address we want to run it. So it's the same host and port like we did previously. And we now need to say which where this app lives. So it lives in the Python in predict.py file. And the app, the variable that let me just open the code. So here we need to point it to this thing. So we need to say where this app lives. And this app lives in predict.py file. And the name of this app is app. So this is what we're saying here. So go to predict.py and take a variable called app. So now let me start it. And yeah, so now it's telling us something that it started Unicorn and it's running on this thing. So now we can go back to this thing again, and I will send another request. And then, yeah, we get a response. So this is our response. Now it's not coming from Flask, but it's coming from Unicorn that is running Flask, but not from the Flask development test server. Okay, next step. I don't know, like maybe a quick, there is one question I can quickly answer before I'm moving on to Docker.
Sure, we can do one. Let me find, I had one lined up for you. So maybe that one's saved for when you do Docker. Could we use, and I'm hoping I'm saying this right as well, can we use Onyx instead of Pickle? So,
Yes, you can use ONNX instead of Pickle. ONNX is just, I think, a format for saving models. I usually hear about ONNX in context of deep learning models. I think you can also use it for simple models like the one I'm showing you here, like for linear regressions, for logistic regression. I have personally not used ONNX for this thing, but probably if it works for logistic regression, then you can use it. As long as you can use something to save it and then load, then you're fine. You can use whatever you want. But it should be able to save the model, and then it should be able to load the model. And the rest is not important, I guess. Okay, so let me go to Docker. So Docker, I will not be able to give you like a good introduction in Docker into Docker. It actually should be Docker file. So for Docker, we need to define a Docker file. And this Docker file explains what exactly we need to install for our application to work, right? So we just need to specify all the dependencies we want to install. And usually when we define a Docker file, we say like what is the base image. So there are base images that we use that contain something. So for example, here we use Python 3.9. So we will take a base image that already has Python of the version we need. So I can just write here from Python 3.9. So Python here means the name of the image, on Docker image, and 3.9 is the tag. And you can just Google Python Docker images to see what kind of images are there. So this is the right link. And if you go there and click tags, you will see that, yeah, there are quite a few of them. So for example, this 3.9.13, so it can be like a minor version. And then there is this Bullseye. Bullseye is a version of Debian, which is a kind of Linux. Here actually it has all these things here. So what I typically use is I use this -slim thing. So I add -slim here. And slim here means that I think it's just smaller image compared to Python 3.9. I don't know how exactly it's smaller and what's the main difference between them, but I go with slim because it's smaller. And this thing has only Python. It has pip, but doesn't have anything else. So now I need to install Pipenv. I don't think I showed you how to install Pipenv. I will show you now. So I will need to do something like pip install Pipenv, and it will install Pipenv. So now, after executing this thing, we will have Pipenv in our Docker image. And now we can copy our pip file and pip file log to our Docker image and then install all the dependencies we have in these files. So we'll do copy. So this copy command copies things from our directory here to the Docker image. And since we have two files, I will use this syntax. So first, this is the file we want to copy, pipenv. Then we want to copy two files. It's pipenv lock. And then the last one is where exactly we want to copy these two files. So we copy them to the current directory, which reminds me that we need to define what the current directory is. We use workdir for that. So I will use workdir/app. So the working directory is the directory where we execute everything. So for example, right now my working directory is this one, right? And like that, here we say that the working directory for this image, this is the place where we will copy these two things, is /up. So it will do something like it will do cd/up, and it will copy these things there, right? So we have this, and then so we copied this pip file, and we want to install these dependencies from there. So I will do now run pipenv install, and it will install the dependencies. But in Docker, so I didn't really tell you what Docker is. I kind of assumed you might have heard about this. So Docker is a way to isolate the application you have from the rest of the system. So it's like you have your, so I have my Ubuntu running here. And inside this Ubuntu, I have a container that is isolated from everything else. So it's kind of its own thing. So it has its own Ubuntu, or I think this one has Debian, its own dependencies that this specific application needs, and nothing else, right? So now we need to make sure that we install the dependencies we want, which is Flask and Scikit-Learn, to this specific Docker image. There are questions?
If I can interrupt you for a second. Someone is asking, should you copy pip file and not pipenv, right?
Yeah, that is a mistake indeed.
Good job, Vincent.
Thank you. Yeah, so I would discover this mistake later, but thanks for noticing, because otherwise later we would lose a bit of time here. So pip, and here I actually also have a typo, and here so many typos. So run pipenv install. But as I was saying, so this thing is already isolated. So here we do not need to create a virtual environment. So here we have a virtual environment, which is kind of like having dependencies just for our project. But in Docker, it's one more layer of isolation. So we don't need to create a virtual environment there. We can just install everything to Python, to the system Python inside Docker. So I hope I didn't lose you here. But what I'm trying to say is we don't need to create a virtual environment here. We just install everything we need to this Docker image. And for that, we need to use two flags. So one flag is deploy, and the other flag is system. I don't remember what is the difference between them, but the main thing here is that when we do this, it does not create a virtual environment, and it uses the system Python for installing the dependencies, right? Okay, now we install all the dependencies that we needed. The next thing we need to do is to copy the model file and the predict.py file. So I will do again copy. So first it will be model C12 bin. Then the next thing will be predict.py, and then the last will be again like the current directory. So what we did so far, we copied the pip file, we installed the dependencies from this pip file, and we copy the model and the predict file. Now we can run it. So for that, what we do is we do entry point. So entry point defines what exactly we should run when we start this Docker image. And here I will just go here and copy this thing. So this is what we should run. So we should run JUnicorn. And I will edit this a little bit. So here each token should be like its own, like this is just how we need to do. So we should, each token in this command should be its own word, and then we separate them like this. I don't know why we need to do this, but yeah, we just need to do this. And also we have this port, right? So this is a port 9696. This is the port where our application is listening for incoming requests. And inside Docker, so in Docker, this Docker container, as I said, it's a thing that is isolated from the rest of the things in our host machine. So we need to explicitly say that on this container, this port should be open. So then we can send requests to this port. And for that, there is a special instruction that say expose. It means that this port should be open. So I think that's all we need to do for this Docker file. Now I want to build this, and hopefully I don't have many typos, so it should work. So I'll just go and do Docker build. Then I do Docker build -t. So here I need to specify the tag name. So this is how we will know how to defer to this image we are building. So I'll just call it churn service, I guess. Service, yeah. And then the tag could be like 0.1, something like this. And then dot. So dot here means that use this folder where we are currently in to copy like all the files that we here specified, like a pip file and so on. So now what it's doing, it's first downloading the model, this Python 3.9 Slim, the base image. Now it's installing Pipenv. So yeah, it's installing Pipenv. Then it copied the pip file. Now it's installing dependencies from the pip file, from pip file log. And it is installing it to the system Python. So it's not creating a virtual environment. And the next thing should be, it should copy these two things, right? Expose the container, and now it finished. So now we can try running this. So this is how we tagged this server, this image. So I'll just do Docker run, and then this server. It's actually this name. So this is not enough. I need to add a few more things. So I need to add -it. We want to make it interactive. And this is needed if we want to stop it from the terminal. Otherwise, we will not be able to stop it. And then I will also add rm. Rm means when we stop, when we finish, when we stop our container, it should remove all the temporary files it created. So let me run this. And now we see the same command as we saw previously. But now the difference is it's not running on our host machine. It's not running in our virtual environment, but it's running inside the Docker container. So this thing is self-contained and it has all the dependency it needs. And now let's test it. So I'll just go to this thing, and the URL is still the same because it's running on our local host, and I will just send a request, and something is wrong. So let's see. So other, yeah. So what I forgot to do is I forgot to add port mapping, which is pretty important. We did expose a port already, 9696, but we didn't map it to a port on our local host because I am still sending requests to localhost, right, to our host machine. And Docker needs to know that if I send something to this 9696, it needs to forward this request to the Docker container. And for that, I need to use this syntax. So it's 9696, the port on the host machine, and then the port in the container. So we want to run the port on localhost 9696 to the port 9696 in the container. Now let me run it. Hopefully now it should work. Let's see. Okay, now it worked, and it gives us the predictions, right? So let me see how much time I have. So I don't think I have actually time to show you how to do cloud deployment, or it's okay if I take a bit longer to do this.
As long as there's time in your schedule, it's okay with us.
Okay, so what I'll do, so I will not take questions right now. So I'll quickly do this thing, and it takes some time to actually deploy it. So while it is deploying, I will take questions, and it should take 10 minutes max, I hope. So let's see. So I want to use Elastic Beanstalk for this. So now we have Docker container, and with this Docker container, we can deploy this model everywhere, anywhere we can, anywhere we want. And like this, anywhere, of course, should support Docker images. So should support deployment with Docker images. So I will go to my AWS account, and I will go to Elastic Beanstalk. So this is the simplest way to deploy a Docker container in AWS. Maybe there are other ways, but this is what I will use. And for this, I want to use a special tool, a special CLI tool, which is called Elastic Beanstalk CLI. So I will, maybe I have it already. Oops, EB. No, I don't have it. I'll do pip install. Actually, I should use pipenv install. I will not use it. I will just 1 second. I want to make sure that I install the correct thing. So it should be AWS CLI, AWS Elastic Beanstalk CLI. That's quite a name, right? So I will install it using pip install. So ideally, I should use pipenv install. So you can pretend I actually use pipenv install for this, because we want to make our virtual environment self-contained. We want to make it to contain all the dependencies we have. But if I do this, I will change this file. I will change this file, and then Docker will see it, and it will need to rebuild the image. So I want to avoid that, and that's why I just use pip here. And now, so I have Elastic Beanstalk. So this is the command we need to use. So this is Elastic Beanstalk CLI command line interface. And let me quickly check the version. So this is the version I have. And now I can say that I want to create a new project with Elastic Beanstalk. It's a B init -p. So this is the type of the project. So init initialize the project, -p type of the project. So for me, it's Docker. And then the name could be, let's say, churn serving. Serving. Yes, so this will be the name of the project. So I start the project, and it created a folder, Elastic Beanstalk, here with config. And then, yeah, there is just a bunch of things. So what is interesting for us, for me right now, is this default region, because I want to use, instead of ES West 2, I want to use Ireland. So I'm now in, so here, oops. So here I am in Ireland, so I want to use the same region, and it's geographically close, more close to where I am now. So I will replace this to EU West 1, which is Ireland, and I will not change anything else here. And yeah, that's the config. So this folder was just created by this command. And before I deploy, I want to quickly test it locally. So I'll do EB local, oops, sorry, local, what is local run, and then port 9696. So it seems to work. Now let me execute it just to make sure it's still working. It is still working, good. So now I will stop this, and I will do EB create churn serving env. So this is something that we will create now in Elastic Beanstalk. So I will execute now this thing. So right now, this will do a bunch of stuff on AWS, which maybe is not super important to know what exactly it's doing. But in essence, it's just taking the model we created, the image, the Docker image we created, and it's pushing it to AWS, where it will be served. So it will take some time. So now let's take the questions in the meantime.
Sounds good. So can the same functions work on a Mac as well?
Yes, everything that I show here will work on Windows, with a slight thing that I said that Unicorn does not work on Windows. But apart from that, it all works on Linux, Windows, and macOS.
Okay. And what can happen if we use Flask Run instead of Unicorn in production?
So what will happen is with the moment it gets 2 requests at the same time, it will not be able to serve the second request. So only 1 request at a time, and it's slow. Yeah, basically it will just be, it will not have the performance you expect to have. So it will not be able to handle the load. With GUnicorn, it's more flexible. You can say that, okay, I want, I don't know, 8 processes to handle this request. So then it's, yeah, you can read some documentation about like how to tune GUnicorn, but in essence, it's just a lot more performant than just Flask.
And will the code be shared? I don't have an answer to that.
Yes, it is already shared. So you go to ML Zoom Camp, and in this it redirects you to this repo, to this folder, and then you go to this 5 deployment folder, and then here you have code, and then all the code that we discussed here is there. So yeah, for example, let's take a look at Docker file. I think it's exactly the same. Let me see. Yeah, except no, I think like it's identical. Like I don't know how I managed. Oh no, like this one and this one, the order is a little bit different. But yeah, and the version of Python is different. But yeah, like the code is there, maybe with minor things, but yeah, check it out.
Okay, and where can we watch the recording? You can watch it on YouTube at Data Science Dojo's channel, as well as on our website, online.datasciencedojo.com. How can we perform model monitoring for the cases where the data isn't labeled?
Okay, that's quite a packed question. So I will do another shameless plug. So we have a course which is about MLOps. So MLOps is like a set of tools and practices, or it's more like a set of practices and then tools to productionize machine learning. And then one of the things there in MLOps space is like after you deploy, how do you actually monitor your models? And then in this course, we talk about MLOps and different components and practices. And one of the modules there in this MLOps Zoom camp is monitoring. So check it out. It has answers to your questions. I don't think we have time to actually answer it right now.
It's a whole nother webinar.
Yeah, exactly. Or 2.
Yeah. So this is from Jacob. Alexia, I was wondering if there are any other follow-up resources that you would recommend checking out. Jacob is in college and free is preferred.
Free is preferred. Yeah, so this ML Zoom camp is quite good. Of course, because I am the author, but not only. So one of the things you can check out. So here I just showed you, this is how you use Pipenv. This is how you use Docker, right? I didn't really talk about what Pipenv is, what Docker is. So then like this is the same module in the same course I already mentioned, which talks about, what Pickle is, like what is Flask, what is Pipenv, what is Docker in more details. Like there, it explains like every line what exactly they're doing. So here I couldn't cover all that, but check it out if this is something new to you. Then if it's not new to you, you can check like serverless, for example. This serverless module is where we deploy a deep learning model to AWS Lambda. So this is pretty cool. And Kubernetes also something I recommend checking out. So this is like you have your Docker image. How can you deploy it to Kubernetes? And then it also explains what Kubernetes is, what kind of things are there, and how to take the model and deploy it to Kubernetes. So check this out. Apart from that, I don't know, check out our Datadogs Club, which is a cool community, and we have a lot of events like similar to Data Science Dojo.
And
let me actually check if. Sorry, I just see that it's deployed. So what I will do now is I will show how to use this. It will not take a lot of time. So I just take this URL and I will go to our thing here. So I will put it here. So this should be HTTP. Here we don't have a port. Elastic Beanstalk by default uses port 80, so we don't need to specify the port. So I replace the URL, I keep the customer the same, I send the request, and I get back the response. So now instead of going to my local machine, it actually went to Elastic Beanstalk. So this is how you can deploy it. And it took, let me see, so it finished it at 6 minutes and we started. So it took like 3 minutes to deploy it, which is not a lot, but also not immediate. And now I want to show you how to actually turn this off, because remember, this is actually paid. So you are paying. So this is not a free service. Maybe there are some parts that are free, but let's assume that it's not free. Like there is the thing called free tier, but I don't really know how it works. So like if you don't turn this off, you will be charged at the end of the month. You don't want to have a surprise at the end of your month. So please terminate your environment. And this is how you do this. So there was a thing called terminate environment, and you just terminate it, and you will not be charged at the end of the month with a lot of money. It will not be a lot, but still, like you don't want to pay like $50 for something you don't use, right? Okay, I think that's actually it for me. So it took 10 minutes longer, but I hope it was still worth that.
Yeah, definitely. All right.
I can take a few more questions if there are any.
Sure. Let's do maybe 5 more minutes of questions and then we can end. So can this be applied to neural networks or computer vision models?
Yeah, we talked about this, yes and no. So first of all, TensorFlow, for example, if you use TensorFlow, it's a huge library. It's not very easy to just take it. You can do this. You can take the Flask app that we created here and just put TensorFlow there, but it will be super slow because TensorFlow is a huge, it's like 2 gigabytes library. So you don't want to carry this kind of library around. What you can use instead is TensorFlow Lite, which is a lighter version of TensorFlow, which only has this serving part. And this is what you can put inside Flask. And then again, so this is something I talk about in here in serverless, but it's not only about serverless. It can also be applied to Flask app that we created here, like this TensorFlow Lite part. So for example, if you want to use Flask, so you can check this TensorFlow Lite thing, like just Google it. You don't have to watch it here. You can also watch it here if you want. But it's pretty straightforward. So you take your model, you convert it to TensorFlow Lite format, and then you can put it inside your Flask application.
Okay, and do you have any opinion on Fast API?
I unfortunately do not. I really need to try it. Like everyone says, like, why do you use this Flask? Like it's not cool anymore. Like cool kids use Fast API. So I'm not a cool kid.
And
but yeah, I've heard many good things. I just need to try it. I'm just out of habit use Flask, but it doesn't have to be Flask. It can be Fast API or any other web service.
And then a question about your book. Does it cover the deployment of TensorFlow?
Yes, it does.
Okay, and why Waitress over Unicorn?
Why? So Waitress is like if you want to do this on Windows, you use Waitress, right? So if you don't do this on Windows, yeah, you don't have to. Like Waitress kind of works everywhere.
Mm-hmm.
Then the question was, like, let me just open it so I make sure I really understand it. Was it Unicorn or G-Unicorn? Because it's like Unicorn, yeah, like Unicorn also works on Windows, I guess. Just didn't test it. I heard it's better, but like to me, they all look the same, right? So I don't know what are the differences between them. I didn't do any benchmarks to say that one is better than another. I know that G-Unicorn works. I know that Waitress works. I know that Unicorn works. All of them will work with Flask. So yeah, there might be reasons to prefer one other over another. I don't have them right now.
Okay, and is it possible to train? The model with updated data also in the production model and not just predict with already pickled or saved models?
Yeah, so again, I would refer to ML Ops Zoom Camp, where we show how to constantly retrain a model. So the process for doing this is called like you create a machine learning pipeline. So in this process, you can easily retrain your model. and then you can update the model that is running in production. So for example, let's say we have this model here, right? But let's say we have some machine learning training pipeline that trains a new model, and then we can automatically redeploy our thing, like our service, when a new model is created. So again, this is more like domain of MLOps, where we automate these things. But like you should have very good reasons to implement this, because it's not easy. It's difficult to set up this process. It's fun. It's like we engineers like tools, experimenting with tools. But like the question is whether you actually need it. Maybe it's okay to use like this model and update it manually every now and then. So
yeah, and if you ask this question or also have this question, we actually have a webinar next week called Putting MLOps into Practice. It's at noon on August 31st with a senior cloud solution architect at Microsoft. So if you have this question or also would like an answer to it, I would suggest joining us next week.
yeah, they will probably show how to use Azure, right?
Probably.
I'm not saying anything against Azure. Actually, at Microsoft, while we are talking about this, they have a really cool article, which is called MLOps maturity levels, I think. Maturity model, yeah. So this is the first link you have, is the article from Microsoft, Machine Learning Operations Maturity Model. So check it out. It's really like it outlines what exactly you can have at different maturity levels, what kind of automation levels, what kind of people on the team you can have. Probably that person will tell you a lot more about this. But yeah, it's a cool article. Maybe to prepare for that webinar, take a look at this. It's a really cool one.
Awesome. Okay, Alexi, I think that's about as much time as we have. So thank you so much for being here and giving this webinar for the community. And thank you everyone for coming. I just want to steal the screen here for a second and actually talk about next week's webinars. So I already mentioned putting MLOps into practice. This is August 31st at noon. And this is with, and I'm going to butcher his name as well, Pipenv Stranghold, and I apologize if I said your name incorrectly, but he's a senior cloud solution architect at Microsoft, and he's going to be talking about putting MLOps into practice. And then we also have Nick Barrett's with us for the 7 ingredients in every great chart. This is Friday, September 2nd at noon Pacific time. And Nick is an independent educator and author specializing in data visualization, dashboard design. So join us next week for these two, especially if you have that question, and maybe my team, we can send an email out with that article that Alexi just shared with us about model maturity. So thank you everyone for joining. Alexi, again,